This tutorial will explain how to conduct a two-sample t-test using the JUMP software. The data that we're using concern fuel economies in miles per gallon for two German automobiles, the Mercedes and the Volkswagen. And both of these vehicles were driven for 10 complete tanks of gas, and then the fuel economies were calculated. Now, note here how the data were entered. We put in our response variable, or the variable of interest, miles per gallon, all in one column, and then we used a second column to label each row as either being a Mercedes or a Volkswagen. This is the way we must enter our data in order to conduct a two-sample t-test in JUMP. Another thing to notice is down here under the columns field that MPG has a purple triangle next to it. That means it's a continuous random variable, as you can see, and auto has a little bar chart there, which means it's a categorical variable. So we need one continuous and one categorical variable here. Now we go up to analyze analyze fit y by x in order to carry out a two-sample t-test. So we slot in MPG here as our response, and we slot in auto, or the make, as our factor, and we click OK. Now there are a couple options we have here. Remember from class that we either have to assume that we have equal or unequal variances. Well, from the scatter plot here, it looks like we're going to have unequal variances. So that is the first method that I'll show you. In order to conduct this test, we click on the Options tab next to One-Way Analysis, and we would just come down to T-Test and click. Below we have the results for this t-test. Notice that the difference it's constructing is Volkswagen minus Mercedes. Keep that in mind for interpretation and conclusion. Also, you need to note here that the null hypothesis that it's testing is that the difference in population means is equal to 0. So that is the null hypothesis that JUMP assumes. Based on that, we get a test statistic, this t-ratio. We get the degrees of freedom that are calculated through the Satterthwaite approximation. We have a two-tailed p-value, a upper one-tailed p-value, or a lower one-tailed p-value. It also gives us the confidence interval for this difference. Now we have a few options here. First one is we can set our level of alpha, and we can change that. Remember that that just changes the confidence interval around. And we also have some options for our graph here. We can go down to display options and maybe put box plots on those to help us see what's going on. Okay. Now, that was the two-sample t-test with unequal variances. So I'm going to go and remove that output by unclicking or unchecking the t-test there. Now let's assume that we're considering the equal variance case. What we do in class is we use the pooled variance in the test, so we need something that has that pooled variance involved there. So if we go down to the second option, to this means, ANOVA, and pooled t option, and click on that, that's actually what we want. Now be careful here, because this gives us way too much output, much more than we want. We really only want to focus on this t-test area here, and that looks very much like the t-test output that we just saw, except now our degrees of freedom are m minus n minus 2, as we've talked about in class, but the rest of the output is still there. And really just look there, don't worry about the rest of the output. This is how you conduct analysis for two means from different populations.